Have you ever wondered why a straw in water looks bent? Or why some light rays do not escape the water at all? Well, in today's video, we'll break it down. A real past paper question on light, refraction, and total internal reflection. Let's go. This question is from June 2018 past paper, and we will go step by step, so make sure you watch till the end. By understanding what the question is asking, we have a ray of light inside the water, hitting the surface and not passing through. We need to identify the process, measure angles, and calculate a new angle. Hopefully you're familiar with it. It's a critical angle. First, we need to name the process when the light does not escape the water. Here we have the torch below the water and the whole light rays being reflected under the water. No light rays escape from the surface of water. The name of the process, it's TIR, which we call it in physics total internal reflection. We draw the normal where the light meets the water surface. And here we have, this is an incident ray, which is incoming light ray from the source of light, which is torch, and I need to draw the normal. Normal must make a 90-degree with the reflectant surface or the boundary between the water and the air. So using the ruler, make sure it is 90-degree, and now I have to place it like this and draw a normal dotted line, which is normal here, and I get the second mark. Remember, the angle between the incident ray and the normal, we call it in physics, it's an angle of incidence. The examiner asking to measure the angle of incidence. So place your protractor to measure the angle, which is already labeled I, between the incident ray and the normal, and the answer for this one is approximately 70 degrees. The examiner gave a range between 67 to 73, so you don't have to worry about the range. The angle of reflection, which is the angle between the reflected ray and the normal. Where is the reflected ray? This is the reflected ray. Where is the angle of reflection? Is between the normal and the reflected ray. Must be equal to angle of incidence. So let me say it's approximately, using the protractor, is going to be 70 degrees. How many marks? I get 4 marks till now. Word about some students, if they are not familiar with the concept of total internal reflection. The total internal reflection happens when light moves from a denser medium like water in this example to a less dense medium, air. Light is completely reflected inside the medium instead of being refracted. The total internal reflection happened or occurs when the angle of incidence is greater than critical angle. Okay, let's move on. Question or section B. The torch is moved and the ray of light now passes through the water surface. So here we might go for the refraction, and the examiner is asking, and I draw a line on diagram to continue the path of ray of light. 2 marks. So for me to be in the safe side, make sure this is the 90 degree. Firstly, I draw the normal. Okay, label this one, which is normal. Makes 90 degree with the surface. Point 2, I know when the ray of light leaving a medium to another medium, it's impossible for the light rays to continue along the same path because we are in different density and according to the concept of refraction in physics, which it means a change in direction and a change in speed. So the angle of refraction inside the less dense medium must be greater than the angle of incidence in water. So because increase in the speed of light, so I should draw the refracted ray with an angle more than the angle of incidence. So here we have to draw the refracted ray like this. And please do not forget the arrow. I get 2 marks for showing the refracted ray or the change in direction and the angle of refraction more than the angle of incidence. You can label this angle as R and this angle as I, but you might get have some concern regarding do we have a refraction here? Definitely, because the angle of incidence is quite less than the critical angle. The examiner might ask you for calculating the critical angle in the upcoming questions or sections. Examiner now asking to state the name of this process. So this name, we call it in physics refraction because you already have a change the direction of the light ray when you go from a medium to another medium. They have different optical density, change in speed and a change in direction. I deserve in the section B 3 out of 3. In CI, state the equation linking critical angle and refractive index. The formula N refractive index 1 over sine C. You might write sine C 1 over n. In double I, the refractive index of water 1.3. Remember, refractive index has no unit. It's a ratio between speed of light in vacuum, speed of light in medium. Critical angle for the boundary between water and air. Give your answer to a 3 significant figure. Please do not forget this one. So you will get 1 mark for showing 3 significant figure. Let me write sine critical angle, it's 1 over n. So sine the critical angle, it's 1 over 1.33. So my critical angle, it's a sine inverse the answer on the calculator 1.33. C as a critical angle, how much? It's a 48.75 degree, which is approximately 48.8 degree. 3 significant figures. Please check the mark scheme. For this one, we will get 3 out of 3. Last section, the torch is moved again so that the ray of light now meets the water surface and at an angle of incidence which is 52 degree. So without spending longer time to think about this one, I need you guys to link the 52 and the 48.8, the critical angle in double I and the new angle of incidence 52. Tell the examiner that the 52 degree as an angle of incidence here more than the angle which is critical angle 48.8. So 52 more than 48.2. So I show the examiner that I understand the sequence in the question. You ask me firstly to calculate the critical angle. Then you have given me a new angle of incidence more than the critical angle. So we might go again for a total internal reflection. It means we have all light rays being reflected inside the water. We have total internal reflection. It means no light rays escape from water. I deserve 2 marks. That's, we have explored the refraction, total internal reflection, and how to calculate the critical angle. If you found this helpful, give us a subscribe for more physics breakdowns. Let me know in the comments if you want more past paper solutions and questions. See you in the next video. Remember, physics is all about understanding how the world works.